the domain of f of x equals 3x plus 2 over the square root of x squared minus 4. The numerator, as you see, it is polynomial, so that means it's all real numbers, so I don't care about it. So what I care is about what? The denominator. So now, the denominator, as you see, is a square root. And when you know that we have a denominator, when I have a square root in the denominator, what is inside the square root has to be greater exactly than 0. So that means x squared minus 4 has to be greater exactly than what? Than 0. In this case now, what we do now to find the value of x, we factorize this one. As we know, we factorize it x minus 2 and here x plus what? Plus 2. Good. When we factorize these ones now, in this case, we are finding a range, not a specific value. This is not x squared minus 4 equals 0. No, to find that x equals 2 or x equals negative, no. This is now a range of values. That means now, when I multiply a bracket here, when I multiply a bracket times a bracket, that means parenthesis times a parenthesis, that means a number times a number, it will give me greater than 0. That means these two numbers that I'm multiplying them, either both of them, they have to be positives or both of them has to be what? Negatives, in order to give me a positive value that is greater than 0. How we study them here now to understand what is the interval that it will give me the domain. If you have like this two parentheses and you multiply them greater or equal than 0, in this case, you're going to have a check table, by the way. It is like a number line. And a number line here, you put, as we know, this is positive infinity and this is what? Negative infinity. Now find the critical values for this one. That means put this one now, x plus 2 equals 0 in your mind, then send the 2 to the other side. So that means it's going to be x equals what? Negative 2. And the other one will be x equals what? Equals 2. Draw these ones on the number line. This one now, as you know, this is 0. And here will be negative 2, right? And here it will be what? Positive 2. Now we have three places. I have here a region of numbers, and here a region of numbers, and here a region of numbers. So you have to study each number in this region. Is it possible to put it in the domain or not? So when I take a number from this place, I take a number that is between negative infinity and negative 2. So I'll take negative 3. I'll take negative 3. When I take negative 3 now, I go to test it here. I go to put it here and I put it here. And I see will it give me a number greater than 0 or no. So here if I put negative 3 minus 2, it's going to be negative what? Negative 5. Good. When you put here negative 3 plus 2, it's going to be negative 1. Now if you multiply these ones, negative 5 times negative 1, will it give you a positive number? Yes, it will give me a positive number. And this positive number is greater than 0. Yes. So that means this place, it works in the domain. Okay, I go to the next region here. I take a number that is between negative 2 and 2, like 0. 0 is here between this one, these two. So when I take 0 now, I go to put the 0 here instead of x and I put it here. 0 minus 2, it's going to be negative 2, as you know. Negative what? Negative 2. Good. So that means negative 2, this one. And here now, 0 plus 2, it's going to be what? It's going to be 2. And 2 times negative 2, that means negative times positive, it's going to be negative. Is the negative number greater than 0? No, it's less than 0. So that means this one here is not included in the domain. Okay, what about the third point here? I take a number that is greater than 2, like 3. When I take 3 here now, I substitute in the green what? Inequality instead of x. When I put here x plus 3, which is 3, x plus 2, which is 3 plus 2, I'll get 5. And here I'll get 3 minus 2, which is 1. 1 times 5 is 5, and 5 is greater than 0, so that means it works. In this case now, where are the intervals that works as domain? As you see, from negative infinity to negative 2. From negative, and negative 2 is not included in the domain. Why? Because if you put negative 2 now in the domain, in the numerator, it will make the denominator 0. And the 0 cannot be in the denominator. So in this case, 2 is not included. So you put it what? Negative 2, negative infinity, and negative 2. And the negative 2 has a parenthesis. That means it's not included. Plus, this is union. That means it means plus. Plus what? Plus the domain that is from 2 to positive infinity. That means this region and this region, as you see, these ones are, that means if I take a number for x, any number I take it that is less than -2, or a number that is greater than 2, it works here. It works here. But if I take a number that is between -2 and 2, it will not work. Okay, try it now. Try it now. So this is now, as we said, this is the domain. Okay, if I take a number now that is between -2 and 2, I take 0. If I put x0 here, what will I get? I'll get x power 2, which is 0 power 2 is 0. 0 minus 4 is going to be -4, right? So that means it's going to be 3x plus 2 over square root of -4. Is that possible to be a number? Real number? No, because square root of a negative number, it can't be. So that means any number between -2 and 2 has to be excluded from the domain. That means it's not there in the domain, and we cannot use any number for x that is between -2 and 2. But other numbers from -infinity to -2 to less than -2, we can use them. And other numbers that are greater than 2 to positive infinity, we can use them to be the values of x. And domain always are the values that I can put them, plug them in, to replace them in the place of x, so that it gives me values for the y.